Well, student, we studied electric field intensity. That equation it is vector F is equal to vector E is equal to F by Q. And another equation we studied electric field due to point charge. Due to point charge means what? Due to single charge. Now please calculate the electric field due to system of charges. Calculate the electric field due to a system of charges. So now the next topic it is about the electric field due to a system of charges. The student is showing figure total number of 4 charges we are drawn on this board. First charge is Q1, next charge Q2, next charge Q3, next charge Q4. Due to these 4 charges, calculate electric field intensity at point P. Calculate electric field intensity at point P. Due to this Q1 charge, electric field denoted by E1. Due to this Q2 charge, electric field denoted by E2. Due to this Q3 charge denoted by E3 and due to this Q4 charge denoted by E4. The total number of 4 electric field lines is shown in this diagram. Distance between the Q1 and P charge denoted by R1P. Distance between the Q2 and P charge denoted by R2P. Distance between the Q3 and P charge denoted by R3P. Distance between the Q4 and P charge denoted by R4P. Okay. Now the next thing is about the explanation from the diagram. Explanation from the diagram. What is the name of this theory? Derive the equation of electric field intensity due to the system of charges. Due to the system of charges. And that answer can be derived with the help of the superposition principle. That equation can be derived with the help of the superposition principle. Because whenever there is a more than 2 charges are there, then always we are using the superposition principle. Okay. As far as this figure, there is a considered system of n charges Q1, Q2 up to Qn. Q1, Q2 up to Qn. Having a position vector R1, vector R2 up to the vector Rn with respect to origin O. With respect to origin O. Okay. Next thing. Electric field at point P in the space due to the system of charges is defined as force experienced by a unit test charge placed at that point without disturbing the original position of charges Q1, Q2, Qn. It is nothing else. Definition of the electric field. Definition of the electric field, force acting on the unit positive test charge. And value of the test charge you select very much smaller, means tends to 0, so that it does not disturb the original electric field due to the charges Q1, Q2 up to the Qn. Okay, now the next thing. Now we can use the Coulomb's law and superposition principle to determine this field at point P having a position vector R. That means what? Point P is having a position vector R. So to determine this electric field, we are using the Coulomb's law and the superposition principle. And we are using the superposition principle. So the student, first of all, there is a electric field E1 due to charge Q1. Electric field E1 at point P due to charge Q1. That is to be given by vector E1 is equal to 1 upon 4 pi epsilon 0 Q1 upon R square 1p R cap 1p. It is your equation number 1. Vector E1 is equal to 1 upon 4 pi epsilon 0 Q1 upon R square 1p into R cap 1p. Because student, we just studied electric field due to point charge. It is given by 1 upon 4 pi epsilon 0 Q by R square. Or simply in short form, it is known as a KQ by R square. Nothing else, we are using that same equation 1 upon 4 pi epsilon 0 Q by R square. But it is a electric field due to Q1 charge. Therefore, we write down vector E1, that is Q1. Distance between them is R square 1p, R cap 1p. Where R cap 1p is the unit vector in the direction of Q1 to P. Where R cap 1p is the unit vector in the direction of Q1 to P. And student, R1p is the distance between Q1 and P point. Is the distance between Q1 and P point. Similarly, student, now write down the electric field E2 due to charge Q2 at point P. In the same manner, electric field due to charge Q2 is given by vector E2 is equal to 1 upon 4 pi epsilon 0 Q2 upon R square 2P R cap 2P. It is your equation number 2. Student, small changes takes place. In place of 1, we write down the word 2. And it is a electric field due to which charge Q2 charge. It is a electric field due to which charge Q2 charge. Again, similar student, R cap 2P, it is the unit vector. R cap 2P is the unit vector in the direction of Q2 to P. In the direction of Q2 to P. Okay? And student, R2P is the distance between Q2 and P. And R2P is the distance between Q2 and P. Okay? Now the next step. Similarly, we can express the equation vector E3, vector E4 up to the vector En due to the charges Q3, Q4 up to the Qn. It is to be given by total electric field vector E of R is equal to E1 of R plus E2 of R plus up to the it is En of R. The simple vector E is equal to vector E1 plus vector E2 up to the vector En. Now write down the equation of vector E1, vector E2 and vector En. So now vector E1 is equal to equation can be given from the equation number 1. 1 upon 4 pi epsilon 0 Q1 upon R square 1P R cap 1P plus for E2 1 upon 4 pi epsilon 0 E2 upon R square 2P R cap 2P plus and dash 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 again there is a plus for En now 1 upon 4 pi epsilon 0 Qn upon R square NP R cap NP. Okay, from the each term 1 upon 4 pi epsilon 0 it is common. Write down that short form or general form of the electric field due to the system of charges. Now using the sigma I is equal to 1 to n. This Q1, Q2, Qn denoted by Qi. R square 1P, R square 2P, R square NP denoted by R square IP. R cap 1P, R cap 2P, R cap NP denoted by R cap IP. Okay, so now this is a general form of electric field intensity due to a system of charges. So well student, there is a similarity. First of all, we studied about the electric field intensity due to point charge, and the next things we studied about the electric field due to the system of charges. Okay.